Today we're going to cover vacuum forming. Vacuum forming is taking a thermoplastic piece of plastic material, heating that plastic, and then being able to form it over a mold of sorts. There's several types of molds that you can bring to a machine. However, for our purposes, typically we are doing positive molds. So this would be a positive mold. We're pulling over, draping over, and then pulling vacuum up around this part. A negative mold, a little bit harder to create. This was like a lid for a deli container. You have the piece, the plastic comes down and it's pulling down into that negative space. So what we'll cover today though, we'll do the positives because that's what we typically do. MDF is a good material to make your mold. Even better, the urethane foam that we use, quick to shape it. Make sure you are cleaning it up to at least probably a 320 grit finish. If you do leave file marks and things like that, they do show up in the plastic. Some things we need to be aware of is molds always need to have what's known as draft. So draft is off a vertical, an angle that's coming back. So typically about 2 degrees per inch for our applications. We get better pulls that way. Think of inverting a trash can. They are going to have draft so that can come back off of the mold. So make sure everything is built that way to maintain that draft. This will be the part that we're going to pull today. And so each one of these layers does have about a 1.5 to 2 degree draft on them. And so if we just set this in the machine as is, the material is somewhat porous, so air will pull through it, but it's going to pull slowly. And so when that happens, we have this nice piece of material that's ready to pull. It drapes over, we pull vacuum up against it, but the plastic's cooling the entire time we've pulled it away from the heat. So we want to make sure that we get a real fast burst of air to pull the part tight. We also want to be able to get air flow into these channels. So these are negative areas in this positive mold. Same with this top area, it's a negative. And so if we pull that without any airflow, we end up with a part that has soft filleted edges on it. The inside here has a real heavy fillet. So the trick there is we want to get the airflow to happen in those negative areas as fast as possible. So we've come in with small drill bits and drilled some holes in the corners. And on the back side, since this is such a large piece, we've drilled some larger holes down for those to meet up to. So now when we pull plastic, we open up the vacuum, it pulls quickly up against our part. And so we do end up with a nice tighter area in the corners, and we do get a better part that way. Materials that we want to vacuum form, styrene is one of the best. It's a low melt material. We do sell that in the shop ready to go for the vacuum form. Acrylics can be used. They do get a little bit more brittle after they go through that heat process, so there's a chance that you will break your part trying to get it off the mold. Other materials that work, ABS is a type of styrene. It's going to be a little bit more durable, but it may be harder for you to get. PET, PETG, some of those are good as well. So that previous mold that we showed, there's the vacuum form part. And then what we were actually after was this small part that ended up being just kind of a rough shovel model. And so we were able to come in and cut our part away there. So let's talk about the setup of the machine. We have 3 basic frames that we've set up to hold our plastic. And so the machine itself has a large frame, and then we have these smaller frames that we drop in. So each one is going to be sized for the plastic that we're selling. So we have a 12-inch piece of plastic, 18 by 18, and we also have 24 by 24. So those are going to mate up perfectly to a frame that holds a box that is going to be 4 inches smaller than that. So the 12-inch frame would have an 8 by 8. The 18 would be a 14 by 14 box, so on. So setting up, it's always good to have someone assist you in your vacuum forming. But we have a door on the top of our frame. So the large frame of the machine opens up, and it will sit on the lip here. And we want to center our frame. There's a hole in the table, so we want to center that up over that. There are some vice grips that go with the machine. So we want to make sure that we tighten these up over the area where they're meeting up with the large frame. And then we want to place our box. Always do the frame first, your wooden box second. So we want to make sure it's spinning. The key for us to get a good vacuum form part is that we are leaving only about an half inch gap, all the way around between our box and our frame. So that's allowing, once our plastic is clamped in, it's allowing it to kiss off on this edge of the box and create a vacuum seal. So with that in place, we have controls here on the panel. We have raise and lower. So that's going to raise the plating up for us and lower it. We don't need to use in and out. That's typically going to be for larger parts that you need to roll the unit out, so don't worry with those. And then the only buttons here that we need to worry about are the inboard heat and then the outboard heat. The inboard is going to take into account any of our small frames that we use. So that will do anything up to 4 foot by 4 foot. And then the outboard heat you use in conjunction with the inboard heat, so it would heat up the entire volume of the heating coils. So make sure, for the most part, any of the small stuff, we're only using inboard heat. So we're going to raise this up. And then I'm going to carefully tape strips of duct tape. And we come in, we're going to get a nice seal in the corner there. And then where we have the extra, we come around the corner and fold it in so we have a nice seal there for our vacuum. So that's transferring our vacuum that was coming from the table. Now it's transferring here to the box where we need it. So now we'll go around quickly and do all the corners, or all the edges, making sure it's down. Now, we want to make sure that we did not move the box because it made it up perfectly with the frame. So we're now. So we just verified that we still have that half-inch clearance around the box. So that's all we need. So now, if we just lay our part on top of the box, we're not going to get airflow around the perimeter that needs to occur. So one trick there. When you get ready to vacuum form, you'll come get the little white box from us. It will have our small clamps for the small frame, and it will have an assortment of washers. So we use these to set our part up off the table. So that is creating an air channel, airflow beneath our part. So when our plastic comes down, air can flow and pull up tight against our piece. Any larger, and then we would have to go to the next size box up, the next size plastic. So we're ready to go. Right now, we have a switch on the back of the machine that will cut on our vacuum. And typically you'll do that as you approach the machine. In the future, there's going to be a shutoff on the wall here for that. So just look for that, but if you don't see a shutoff panel, come around back. And we want to cut on the lower left breaker. So as that's running, we're building up a vacuum on this reserve tank here. We want to make sure that our valve is in the horizontal position. That's closed. So we're going to pull a negative pressure on that large tank. Okay, so the vacuum pump ran for about a minute, minute and a half there to bring that reserve tank down to pressure. Once it gets to about 20 inches of mercury, it has a switch in there, it'll shut off. So when that has happened, you know that you have the reserve, you're ready to start heating up your plastic. Make sure nothing is on the table. You can't go through this whole process and then the frame not come all the way down like it should because you blocked it. We need to raise up about 2 or 3 inches. We insert our plastic. We have a door. Drop it down. We have our small clamps that come in. Sometimes you have to tighten those up to fit, depending on what size plastic you may have to adjust it to. All right. And so we're ready. So remember, inboard is going to be these 2 rows of heat. That's all we need for a small piece. If you're doing something super large, which we kind of discourage against because there's a lot more failure risk, you run both in and outboard. So cuts here on the left. As we heat it up, we raise the material up into the plastic or into the heat. So typically, I bring styrenes down to where this piece is here. That's how we can kind of control heat. If you were taking a piece of acrylic, you need to bring it down at least to here, probably somewhere in this zone to get it to heat properly. Acrylic has a tendency, the moisture will cook out real fast. It'll bubble the top surface before it ever gets ready to pull. So you want to kind of keep it slow and low. So as styrene is heating up, it's going to take it again a little bit of time. Styrene will go through a rippling, so we'll see that on the surface. It will still be rigid at that point. After that, styrene goes to a taut stage where it's tight in the frame. Acrylics, you'll notice, they'll go through the same rippling effect, but then as they start to get to temperature, they'll start bellying down into the frame. So if you had a 24-inch frame, you're going to have a belly on it probably that far, so where it's sagging. So we're just now starting to get a ripple on it, so it's just slowly heating up. We talked quickly earlier about making sure we have draft on models. So draft is this direction. You need to make sure you don't have undercuts. So you can't have a sweep cutout on your part because the plastic will get stuck and you won't be able to pull it off easily. So make sure you're always playing with the draft and not doing any undercuts. So we just went through the ripple stage and kind of fell a little bit. So we're here, we have this stick with the rounded nose on it. We can come into the corners and see that the plastic is pliable, but for styrene, it's nowhere ready. Styrene, especially this 080 thickness, it has a nice soft feel, like pressing into an inner tube or a thin piece of rubber like that. So we talked about 080, that's our thickness. As you pull tall pieces, your 080 thickness is going to get stretched. So we went from 080 to like 060 here in the sidewalls, and then this piece pulls last, and so it's a lot thinner at like 035. Beware of taking thin materials over tall items because it will get paper thin. So we're getting close. Not quite that rubbery feel that I'm after, but it's getting very close. Students want to try and time this, and if you time this, it took 2 minutes to heat up. The next one's going to take less time, so you can't really time it because the heater, the oven's already warm. So I feel like we're there. So we'll cut the heat off. So we'll lower the table all the way down, and once the table hits all the way down, we will open up this valve. Okay. We're not going to open the valve on the way down because we lose that burst of negative pressure that we're after. So here we go. Now the vacuum opens. And so we leave the vacuum valve open. We're losing a little bit of pressure on our box. So the vacuum pump's going to kick in and it's going to keep your part up against the mold. If we release the vacuum right now, there's a good chance that our part's going to swell off of our mold. So we want to make sure the mold is cool, or the plastic on the mold is cool before we release that. So one way of telling is to come in with the opposite end of the stick. We can come up against that edge that's not our part, and we can see that I can still press into it. So it's still soft. So we need to wait for that to harden up. Once that's happened, then I try to look for the top area, make sure that I can kind of touch it for 2-3 seconds. So after you're done with using the machine, always make sure you are shutting off the vacuum pump. It will continue to run if you do not do that. So now we just need to raise it up about 2-3 inches. And we'll come in and we'll see if we can knock it loose. So clamps sometimes are high. There are gloves you can use. But there's our part. So there are times when maybe you don't have enough draft, you're not able to bump it back out. at the machine. So if that's the case, oftentimes you'll have to take it into the shop, try to get air around the edge, the air gun, see if you can blow air and pop it back off. There are other tricks of taking drills and drilling small holes down, trying to blow air into that as well to kind of pop it off. So that's just kind of a basic overview. Hopefully you'll come to the shop and ask more questions or go through another tutorial.